Hello, this is Alana Tucky, and in this tutorial I'm going to show you how to do 3.3.5 from the Math 133 Sullivan text. Now, where this problem falls in your particular homework set, I don't know, but this will be number 5 if you opened up the physical book. So I'm going to click View an Example. It says the following data represent the high temperature distribution for a summer month in a city for some of the last 130 years. Treat the data as a population. Okay, so here are the temperatures in degrees Fahrenheit, one assumes probably in the US, and there were only 2 days that had a high temperature of 50 to 59 in, let's say, July or August, since it says a summer month, whereas 332 days had a high temperature between 60 and 69 degrees Fahrenheit, and so on. So one of the first things I'm going to do, I want to approximate the mean and standard deviation. So I'm going to click on one of these three. Now I have a few options. I could open it in StatCrunch, which is a lovely program available online. I can open it in Excel or copy it to the clipboard. I'm going to open it in Excel. It doesn't really matter where I open it at, just as long as it gets open. And I'm going to zoom in on this so you can see it a little bit larger. So there's the distribution temperatures, and there are the associated frequencies. So I want to find the mean and the standard deviation, but in order to do that, I'm going to need to find this class midpoints first. These are the classes from 50 to 59. And technically, this is 59.9999999 forever, right? So if it was 59.5 degrees, for example, it would fall into that first bin. So I want to be able to find those midpoints. So I'm going to left-click on this column by choosing that kind of downward arrow, right-click and insert, and that's going to insert a column. I'm going to call this midpoints. Now, if you're doing this by hand, which I'm assuming you are, then you just make a table that looks like this on your paper. Right? You fill out the temperatures, and then you fill out the frequencies, and then you make a space in the middle for midpoints. When they wrote it for us in the problem, let me grab it back, they wrote it horizontally, but we have to, usually work with them vertically, even though there's no real difference in the orientation of the table for how we do the problem, but it's just more common for us to use vertical orientation rather than horizontal orientation. All right, now we have to remember how to find midpoints. So let me pull up the notes from that section. Here we are. These are the notes from section 3.3, and in there we reiterated what we learned actually in section 2.3, which is that in order to find the class midpoint, what you need to do is find the middle of consecutive lower class limits, consecutive meaning one right after the other. So you add up the consecutive lower class limits and divide by 2. So in this particular example in the notes, it was 40 plus 50 added up and divide by 2. So that's what I'm going to use for my particular problem. I want to take 50 and I want to add to it 60, and I'm going to put those in parentheses because I want the computer to add those two, and I want to divide it by 2. Now that's how to do it in Excel. If you're using a calculator, that's fine. It's the same principle. Parentheses 50 plus 60, close your parentheses, divided by 2. Or if you have the new 84s, actually any 84 can be upgraded and should be upgraded. So you hit alpha F1, number 1, this is the fraction menu, and you want n over d, numerator over denominator. And you type 50 plus 60, and the computer knows that those are grouped together. Go to the bottom with the arrow key and hit 2, enter. Now when you hit alpha F1, if this menu does not come up, that means that you are not on an upgraded TI-84, and you should be. So make sure that you are on an upgraded TI-84. If not, then seek out my videos for how to upgrade it yourself, and or come in to see me, go to see your professor, go to see whomever, and get it upgraded. Tutors can help you with it, SI leaders can help you with it, other instructors, myself. And many students can just do it online by connecting their TI-84s to their computers, and I'm downloading the new software, and it's called an operating system. So downloading that operating system and upgrading it. And again, there are video tutorials on how to do that on my YouTube channel. All right, so now that we found the first one to be 55, then we need the next one. Well, you could do the same thing. You could say, okay, equals, it's 60 plus 70, close your parentheses, divide by 2. But you could also notice that there's a pattern going on here. The lower class limit's 50, the next one's 60, the next one's 70, and so on. They're all 10 apart. Similarly, the upper class limits are all 10 apart, 59, 69, 79, 89, and so on. So if they're all 10 apart, what we could do is just take our last number and add 10 to it, and then do the same thing again. Take 65, add 10, and so on. And again, you don't have to do Excel to do this. Most of you are probably very aware that 75 plus 10 is 85, 85 plus 10 is 95, and 95 plus 10 is 105. And I'm just using Excel as a typing tool here, but you could easily just be handwriting this on a sheet of paper for yourself. Okay, now these are the numbers that I want. I want to put this column in L1 and this column in L2 in the calculator. So I'm going to go grab the calculator. I'm going to go to Stat. I'm going to go to Edit, which is number 1. I'm going to clear out all this old rigmarole from some old problem that I don't even remember anymore. Up, clear, enter, over, up, clear, enter. I'm going to type my midpoints in the first column. So 55, 65, 75, 85, 95, 105. And you can see the buttons I'm typing because they're lighting up in red. So 105, enter, and so on. Now I'm going to hit the right arrow, and now I need to type in those frequency values, and I truly don't remember what they are. So I'm going to have to make my screen smaller and go see them. There they are. So 2, enter, 332, enter. And of course, every problem will have slightly different numbers here for these values, so make sure you pay attention to your numbers. Don't use these example numbers. All right, so there they are. Now I'm going to go to Stat, Calculate, number 1. I'm going to tell it that my list, my data list, if you will, is L1. That's where my midpoints are. And then my frequency list is L2, because that's where the frequency or relative frequency values were. Either one would work. And then I'm going to go down to Calculate and press Enter. And then the calculator basically finds the average, keeping both columns in check. So it knows that the values are in L1, but then the frequency values are in L2. And it tells us that the mean is 80.82. So let me go back to the problem. So you could just write this on your paper. Mean is 80.82. And then we want the standard deviation. Let me go back to the problem. So it wants the approximate mean and standard deviation. They're approximate because we're using midpoints. Midpoints mean that you've inherently lost parts of the data. So since you don't know the actual numbers, you only know general terms of 50 to 59, 60 to 69, your data set is approximate, or your values, excuse me, that you calculate, your statistics you calculate, namely the mean and the standard deviation, they're approximate. So we found the mean to be what the computer finds, 80.8 right there. And now we need to go find the standard deviation. And you can see in these instructions, they're doing everything by hand. Well, unless your professor wants you to, we don't need to do this all by hand. The computer found it for us. It's right here. Sigma x is 8.345. Now, why do I use sigma? Well, because it said in the problem to treat these data as a population. So since we treat the data as a population, we want standard deviation sigma, which is this little symbol right here. It's the population standard deviation. It won't matter for the mean because the mean is the same calculation no matter which way you do it. Now, grant you there's a different symbol for it. Because it was the population value, we should label it as mu. There it is. Okay. So you should be writing those symbols when you write this by hand on your paper. So the mean is mu because it's a population, because data are a population. We'll use mean, mu, and standard deviation sigma. And the standard deviation was 8.345. Not 346, 345. 346 was S, but this was not a sample, so therefore I want to use sigma. And there are the results. All right, let's go back to the problem now. So part B is pretty obvious. It's just look at the frequency histogram, notice it's bell-shaped, and you can honestly tell it without even looking at the frequency histogram if you just look up at these numbers. Starts low at 2, goes up higher, higher, and then lower, 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 right? So it's making a bell shape. Now, since it's bell-shaped, that means we get to use the empirical rule. The empirical rule says that 95% would be within, well, let's go back to the notes, shall we? Back in section 3.2, we learned that if a distribution is roughly bell-shaped, which this is, the histogram just proved it, then approximately 95% of the data will lie within 2 standard deviations of the mean. Okay, well, we can use that. Now remember, to find 2 standard deviations away from the mean, your center is either mu if you're talking about populations, or x bar if you're talking about samples. Since we're using a population, we're going to use the mu value. And we want to add on 2 sigmas to find 2 standard deviations to the right, and subtract away 2 sigma to find 2 standard deviations to the left. All right, so let me type that up. Okay, so from the empirical rule, 95% is within 2 standard deviations of the mean. We'll call that. So I want to find mu. Put in, sorry, wrong button, 1 second. There, I want mu take away 2 sigma and mu plus 2 sigma. If I can find those 2 values, I will have my results. I'll make them green. Okay, so mu is 80.82, and I want to subtract away 2 times 8.345, which according to Excel gets me that number right there, 64.13. Now if you want to see it on the calculator, I can just start typing because I'm in the home screen. So 80. Can't remember the number, 82, take away 2 times, or if you like 2 parentheses if you want, 8.345, and there you have it, 64.13. And then to find the other number, you're going to take 80.82 plus 2, and if you want, you could use the times symbol if that makes you more comfortable, 8.345. Time symbol, parentheses in this situation are the same thing. They both mean multiplication. So 97.51 is the other number. Oops, wrong screen. And again, if you want to find it with Excel, you just take, well, you can even do it with cell references. 80.82 plus 2 times that reference. And there you have it. Excel is really nice because it allows you, instead of having to sit there and type the numbers, you could actually use cell references instead. My mu is in cell C10, my sigma is in cell C11, there you have it. Or you could go type it on a calculator and find it. Either way, you want to come up with these 2 numbers. And I believe these were degrees Fahrenheit, right? So those would be the units for each of those problems. All right, let's go back and double check me. See, 80.8 take away 2 times 8.3. They only kept 1 decimal place. That's all right. Every problem's got a different amount of decimal places to keep. So I could do that as well. But the principle still holds. Right? So if I wanted to 80.8 minus 2 times 8.3, there you go, 64.2. And the same would hold here if I did that, 80.8, 8.3. The beautiful thing about Excel, if you use a cell reference like this, then once you change one number here, then it automatically changes the numbers down here, which is nice. And then you don't have to go retype it into a calculator. Well, whichever way you want to do it, calculator or Excel or a combination thereof, that's how you do this problem. You can write it all out by hand if you were doing this on an exam or a paper pencil packet or a worksheet, for example. I hope that helps.